Good morning, everybody, and welcome to our Essentials 40S class. Today, what we're going to do is we're going to start the trigonometry unit. Um, so, if you take a look at our trigonometry unit, you'll find that our topics are kind of short, right? It's not a lot of lessons to go in here. So we have lesson 1, introduction, which we will do today. And then sine law, cosine law, and an application of sine law and cosine law. So it's going to be a short one, but important one as we go. Um, so here we go. Just to let you know that as we are starting this lesson, our unit, we only have 3 units to go. So way to go. So keep up the good work that you're doing. Yeah, we're almost at the end, and I'm so proud of you that you're still watching this and you're still keeping up with your work. So, anyways, today what we're going to do is we're going to talk about introduction to triangles. If you've taken Essentials 30 either last semester or last year, we did triangles before, and then you're probably thinking, well, we're going to do triangles again. Yeah, we're going to do triangles again, but we're going to talk about other ways to solve a triangle. So we know this. I'll just read on this one. A triangle is a three-sided figure. So we know that. Everybody knows that. Although it has 3 sides, it actually contains 6 parts. Okay, well, what are they talking about 6 parts? In terms of 6 parts, there are 3 sides, and there are 3 angles. Okay, so this is a picture of a triangle. So the sides are, the straight lines there. So that's the side, 1, 2, 3. Those are sides, the lines. And the 3 angles. So what are the 3 angles? Angles is basically, when you think of like a door, it's how it from one side swings to the other side. So that's right here. Angle is right there. That's one angle. The B angle, the second angle, and then the third angle, angle C. Okay, so I'm gonna name a little bit of like more parts in here so that we get, we can refresh our memory of our triangles. Because I know some of you might have taken this, a year ago or so. So if we want to solve problems using triangles, we will need to understand a bit about naming the parts of a triangle. So this one over here, you'll see that the triangle has there's A, B, and C. What are those, right? So a triangle above is called triangle ABC, and it's just a way of naming a triangle. And you can see here A, B, C, those are the corner points, which are called vertices. Okay, well, don't worry about those one right now. So the 3 angles are located at the vertices. Okay, so this is the word vertices, and are shown using capital letters, uppercase letters. And you will see why in a second. So in this triangle, right, the corners, okay, so vertices are the corner points. Vertices are corners, and are shown in capital letters, uppercase letters. So each angle has its opposite to it. Each angle has a side that's opposite to it. So they're using the word opposite. Okay. Well, the word, if you've taken Essentials 30, we talked about opposite side quite a bit. So what does the word opposite mean? Opposite means across. Opposite means right across, across. Okay, well, if somebody says, hey, I'm opposite to you, or I'm sitting opposite to you, well, we have to know where the other thing is coming from, right? So opposite means across from what? Across from the angle. Okay, so in this particular case, let's say the uppercase letters, those are indicated as angles. Okay, and right across angle A, right across angle A is side A, and sides are indicated as a lowercase letter. So if this is uppercase A for angle, opposite to that is a lowercase a for the side. Let's take a look at this one. Angle B. This is the angle B. Angle B, like if you think about this, is opening up. I'm gonna get two pens here. So angle is right here. This is our angle, right? Where the opening, right? The opening, or the swinging from here to the next line. This angle B here opens up to side B, side B. And then looking at angle C. So this is my angle C. So this is right there. And this angle C opens up to side little c, side little c. Okay, so just to kind of some information in here, we're going to see X all the time. We're going to see theta, this little symbol in here, what do they mean? So in this section of the course, we will be trying to find the length of the missing side. And the missing side, we will usually call it X. Or we can also figure out the size of the missing angle. And the missing angle is the symbol that we're going to use is this symbol. You would read that as theta. Theta. It's a Greek letter. So there's that introduction part. Now the very first thing that we're going to learn about the triangle, and then this is always true for any triangle. For any triangle, this is always true. The sum of the three angles in a triangle is always 180. So the sum means total, means add them all up. Okay, so the word sum means total, to add them all up. The sum of what? The three angles. The three angles in a triangle is always 180 degrees. So that's a really great information that no matter what shape of the triangle it is, no matter how big or how small the triangles are, the angles will always add up to 180 degrees. So we call it 180-degree rule. Now, this is important concept, which we will use quite a bit. So now let's take a look at this one. Example 1. Calculate the size of the angle in each of the triangles below. Now, when we have this triangle, we know that I add these up, it all had to add up to 180 degrees. Rule 180 says that if I add 47 degrees plus 62 degrees plus whatever this angle is, I'm going to call it theta, it had to add up to 180 degrees. What did I just do here? 62 degrees. 47 degrees plus 62 degrees plus theta has to equal to 180 degrees. So what we're trying to say is to solve for theta. Solve. That means we have to calculate theta. Well, when it's set up like this, we're thinking, well, this plus something, what is that something that adds up to 180? So what we can do is we can go theta. I know that all these three angles add up to 180. So what I could do is I can just take 180 minus 47 minus 62, and whatever remains from that 180, that would be our theta. Okay, so that's basically the way I think about it. If I know the two angles, and if I take them away, whatever remains will be our theta. So I'll do that right away. You can do it with me. Okay, and I get 71 degrees. 71 degrees. So this one is 71 degrees right there. Okay, right there. Good, that's not bad. You know, there's a name, we will talk about it, but there's a name for this kind of triangle when all different angles are different measurement of angles. So I'll talk about that later. I don't want to get too excited and get ahead of myself. Now, this one here, what do I know? I know that you have theta plus 30. I know it has to add up to 180 degrees, right? Because that's what it says in rule 180 all the time. Okay, so 30 degrees plus something will give me 180. So what you could do is you could set it up like this. Now, because I have two of these things, okay, I can go 180 minus 30. 180 minus 30. Well, what's that equal to? 180 minus 30. It's going to give me a 150 degrees. 150 degrees. But 150 degrees is for both of these theta. Okay, so that's for 150 degrees is for two of those theta. So what we need to do is I had to divide it by 2. I had to divide it by 2. 150 divided by 2 because I have to split it between the two angles. So divided by 2, it's going to give me 75 degrees. 75 degrees. So that means this theta here, that theta there, is 75 degrees. And then this theta here is another 75 degrees. Okay, now if I go here, I'm just going to double check my work. So if this is 75, and if this is 75, and this is 30, does it add up to 150? Let's see. 75 plus 75 plus 30. Yes, it does. It does. So 180 degrees. So that means it's correct. Okay, so that's just a kind of a review of the 180 degree rule that we talked about before. And this, if this is something new to you, you've never seen this one before, it's not bad. It's pretty straightforward. Okay. So now that's part A of that. Now we're going to do part B. So what does a part B look like? Part B looks like this. Triangles that are named according to side length. So all of these things that we're going to talk about are all triangles, but they have a specific name depending on their side length, depending on their characteristics, right? So the very first one that we're going to talk about is the equilateral triangle. Now, if I actually dissect the word equilateral, so I'm going to write it down here. Equilateral. Okay. The equa means, that's a short way of saying equal. So that means equal. And then the word lateral, actually the word lateral is used in sciences, okay? And when you say lateral, it means side. So equal for equa, and then lateral means side. So put it together, equal side triangle. So that's basically what it is. The triangle have equal sides. So an equilateral triangle is a triangle where all three sides of the triangle are equal in length. Okay, so the interesting about equilateral is that all of the sides are equal. That's a given. But another interesting thing about equilateral triangle is that all angles are equal. So we're going to read on, okay? So it says here, these are all the examples of equilateral triangle. So an equilateral would be a triangle, a small triangle, 3 centimeter, 3 centimeter, 3 centimeter on all three sides. You can have a big one, and it's 14 centimeters on each three sides. And then 7 kilometers and 7 kilometers and 7 kilometers on each side. Okay. Now, sometimes we don't label everything on each side. So sometimes in some books, to show that all three sides are equal or some sides are equal, they use hash marks, okay, to show that which side lengths are equal. So instead of saying this is 3, this is 3, this is 3, I'll just go here. This is 3. I can just go like this. Okay, so that will actually save me from writing so much. And then because this is all three sides are equal, I can just go like this. Okay, that shows that all three sides are equal. And then this one, that shows all three sides are equal. You know, back in the olden days, you know, these mathematicians going back to, my gosh, Pythagoras, Socrates, they don't have a lot of paper. They don't have a lot of pens and pencils. So what they do is they actually do things to make it shortcut. And that's a way of shortcutting our writing, right? I actually thought that mathematicians are just don't want to write so much. It's actually not the case. It's just that paper and pencil are not easily accessible. So anyways, that's history. Now here, another thing about the equilateral, besides being the fact that they have equal sides, all equilateral triangles are equal length, and the angles are also all equal size. Okay, so all sides are equal, and all of the angles are equal. So what does that mean? Well, if they're all equal, what are they? Well, it still has to follow the 180-degree rule. So we can take 180, and divide it equally to three of those angles. 100-degree angle divided by three angles. So you're going to get 60 degrees for each angle. Okay, so that's a great characteristic of equilateral triangle. So all sides are equal. Okay, so this one here, this is interesting. The only thing we know about is that all these sides are equal. We don't know how long they are, but we know that they are equal. But because we know all three sides are equal, we can say that all angles are equal. Okay, so that's that one. Now let's go and move on to an example. Equilateral triangle in example 1. Two palm trees become unrooted from the sand on the beach and start to fall. So they start to fall like this. They stop falling because their tops touch. Now the trees make an equilateral triangle with each tree on the ground forming a side of the triangle. So they kind of gave us a picture of what that's happening. So this tree fell this way, and then this tree fell that way, and it forms an equilateral triangle. So without this palm tree, I can say, hey, this is equilateral triangle. I can go like that, right? So state the size of the angle at each tree forms with the ground. So this tree forms with the ground. So this one is, because it's an equilateral triangle, then it's going to be 60 degrees. And then this is also 60 degrees. Okay. Now, if there is 30 meters between the base of each tree. So if this is 30 meters in here, right there, 30 meters there, how tall are the trees? Well, they've already stated the fact that this is an equilateral, or they form an equilateral triangle. So that means if this is 30, that also means that the trees are also 30 meters as well. So it's 30. So if this is 30, then that means this is 30, and then this is 30 meters. Okay, so that's great. Now this is an interesting one. We see this the question came from a provincial exam, so it's kind of nice. A student is solving math question involving a 100-meter truss bridge. Now, if you pass by a bridge, you will see like a whole bunch of triangles kind of forming, right? Well, the reason for that is that the strength lies in the triangle. There's no other shape that is stronger than triangle. Triangle is the strongest shape. Okay, that's why a lot of the structures have a lot of triangles in them. So it's okay. So the bridge is made of 7 triangles. Well, where did the 7 triangles come from? There's 1, 2, 3, 4. So you got 4 upright triangles, and then you have the ones that are facing down. So you got your 7 triangles. And what's a great thing is we got the 7 equilateral triangles. Now that is already kind of giving us a hint or some kind of an information about this structure. 7 equilateral triangles. So that means because they're equilateral, then this are equal, and this, and this are all equal. So all of these are all equal. We don't know what their sizes are. All we know is that they're equal. Okay. So now because all of the sides are equal, and this is equilateral, that means all of the angles are also equal. Okay. So in this particular case, it says sketch one of the bridges triangles, and state all sides and angle measurement. So, well, it says sketch one of the bridge. Okay, so I'm just going to sketch one bridge triangle. All I know it's they're equilateral, so I can do that. And because I know that they're equilateral, then that means this is 60, this is 60, and this is 60. Okay, so I can do angles. Well, what about the sides? What can I do with the sides? Let's see this one here. This part here, they are saying that this length is 100. So this whole length is 100. Now, if this is 100, and then there's 4 parts to it, so there's 1, 2, 3, 4, I can go 100 meters divided by 4. That's this part here. 1, 2, 3, 4. That makes it 25 meters for each side. So that means each side would be 25 meters here. Now, if this is 25 meters right there, then that means this is 25 meters. And this is also 25 meters. Okay, so we've created one triangle. Sketch one triangle and state all sides. We stated all sides and we stated all angles. Okay, so if you happen to walk close to the bridge, you'll see a whole bunch of triangles. If you're driving close to the bridge, you're going to see a lot of those triangles as well. Okay, so we talked about equilateral triangle. Equilateral means all 3 sides. Now here's the other type of triangle that is called isosceles. Isosceles. That's how you would say it. An isosceles triangle has 2 sides that are equal and one that is different. The triangles shown below are isosceles. So 2 sides are equal. Okay. Now, because these 2 sides are equal, what I can do is I can put a hash mark right there, these lines there, to show that they're equal. I'm not going to do it for this side because this is not 12. Now this is looking at this triangle in here, 4 centimeter on this side, this is 4 centimeter on this side, these two are the same, so I can go like that. And then for this one, we don't know their sides, but we know that this side and this side are equal. And this one's very obvious that this is not equal to that. Now, the great thing about isosceles triangle that we know that it has 2 equal sides and they actually have 2 equal angles as well. Equal angles as well. So in this particular case, 2 sides are equal, this and this. There are 2 angles that are equal would be these angles right here, right? So if I go over here, I'm just gonna get something. Okay, so I got myself a toothpick. It's better. So if these two sides are equal, then their angles must also are equal. Good thing I'm close to my kitchen here. There you go. That's great. So this angle opens up to this side, right? Angle C opens up to the one right across. And if I go this way, and this angle opens up to this side, if these sides are the same, then the angle are also the same. Okay, so two sides that are equal, that means two angles are also equal. Now let's take a look at an example here. It says again, an old exam question. It's kind of nice to see these things. A community group is building birdhouses. State the type of triangle that is shaded in the diagram. So when we just focus on the shaded diagram here, just gonna draw that out here. So these two sides are the same. These two sides are the same. So what kind of triangle is this? What kind of triangle is this? Well, in this particular case, this is 120 degrees. 120 degrees. And this is 36 and this is 36. Two sides are equal. That means it's an isosceles. Okay, so two sides are equal, so that means an isosceles triangle. Okay, so that one's not bad. Now, state the measure of angle C in the triangle here, ABC. So this is angle A, angle B, angle C. Well, what we're going to do is, because we're now looking for a missing angles here, these and these sides are the same, so that means this angle that opens up to that side and this angle that opens up to that side must be equal. So angle B is equal to angle C. Okay, so this is probably the very first time you've seen me use this symbol. This means angle. Angle B and angle C are equal. So if you want, we can call it theta, and we can call this theta. So it kind of turns us back to what we had earlier. We said that the sum, we're going to use rule 180 degree, the rule 180 degrees. What does that say? So theta plus 120, that all had to add up to 180 degree, because all of the angles in a triangle always add up to 180 degrees. Well, what am I going to do in this one? I can take away 180 minus 120. Okay, that's going to give me 60 degrees. And the 60 degrees, I have to split them up to those two thetas. So that means I have to go 60 divided by 2 equals to 30 degrees. So each theta is equal to 30 degrees. So angle B, so I can say angle B, which is equals to angle C, which is equals to 30 degrees. Okay. So that's a great way to bring what we learned from Rule 180 into this type of question. Okay, so what do we have so far? We've done the equilateral triangle and isosceles triangle. Now, scalene triangle. An scalene triangle is a triangle that has sides of 3 different lengths. So now this one here, three different lengths. Since all side lengths are different, all of the angle should be angle measurements. Okay, because it's confusing. Call it angle. Since all of the side lengths are different, all of the angle measurements are also different. Okay, these triangles typically need a more advanced strategy, which we will talk about later on, like sine law and cosine law. Okay, so don't worry about this one for now. We will talk about that when we get there. So what we're trying to do is trying to see that all of these three sides are different. Now, if three sides are different, that means three angles are different. So that's the main takeaway here. Main point is that, or points, three different side lengths and also three different angle measures. Okay, right? Because it can't be the same. You know, maybe this is a good time to kind of talk about this. I know it's not touched upon this, but when you look at this one in here, which one do you think is the biggest angle? So I'm going to call it angle A, angle B, angle C. And you'll notice that the biggest angle here is angle A. It has to open wider. It has to open wider to accommodate the 32-meter length. So the biggest angle opening will give us the biggest length. And then angle C is the smallest angle opening. I'm going to get my toothpick back. Okay. Get my toothpick back. So it has to open not so big so that the opening here, the side that it opens up to, is also not big. Okay, so small angle, small side, opens up to the small side. That's a great idea. We will learn that again or see that again. So now, what have we done so far? So in part A, we talked about Rule 180 and how we can use that. In part B, we talked about different kinds of triangles, different names of triangles depending on the side lengths. Now we're going to take a look at part C. How do we name or identify a triangle based on their angles? Okay, it's like what do we call the name of the triangle based on the angles? The very first one that we're going to take a look at is called right triangle. So a lot of us are very familiar with this right triangle. So a right triangle is a triangle that contains exactly one 90-degree angle. The 90-degree angle is typically shown with a box, like a square on the corner. Note that the right triangle can be scalene or isosceles if two sides attached to the right angle are the same length. However, a right triangle cannot be equilateral because, as you can see, when we looked at this earlier, equilateral have all 60-degree angles, right? So here, this is a right triangle because it has a 90-degree here. We don't usually write 90-degree here. We just write down the little tiny box or little square there. But when you see that, that tells us it's 90 degrees automatically. And then this one here, this is 90 degrees right there. Okay, so when we look at this one, hey, this is a right triangle, and it's 512, and then this one here is going to be a big side. So this is called a right scalene triangle. So this, if we were to name and to classify this one according to, it's a right triangle, and it's, to be exact, it's right scalene. And then this one is right, because there's a right angle in here, right isosceles triangle. So this is a right, I'm going to write it down, right scalene triangle. Okay, because there's a right angle in here and all three, okay, you don't know all three sides are equal, are different, but it will be different. And then here, these two sides are the same. This one is different, so this is going to be a right isosceles triangle, to be exact. Now let's take a look at this one. Acute. What is an acute triangle? An acute triangle is a triangle that contains angles that are all less than 90. Okay, so acute means smaller than 90 degrees. Okay, so when you look at this one, acute triangle can be equilateral. All equilateral triangles are acute because all of the angle is 60 degrees. It could be isosceles, or it could be a scalene triangle. Okay, so this one here is an acute because all of the angles are less than 90 degrees. So if we want to classify this specifically, this is an acute equilateral triangle. And then this one, all of the angles are less than 90 degrees. So this is going to be an acute, okay, this is acute isosceles. Isosceles because two angles are the same. So that means these two sides are equal. Okay, so acute tells us these two angles are all three angles are less than 90 degrees, and it's called isosceles because all these two sides are the same. And then finally, all three angles are different, and then so that makes it an acute triangle, and then all three sides are different lengths, so this is acute scalene. So acute talks about the size of the angles, scalene talks about that all three sides are different lengths. Okay, so there's a lot of talking in here. Sorry about that, but that's just how this is. So obtuse triangle. So we talked about a right triangle that has 90 degrees. Acute triangle has all small angles less than 90 degrees. Obtuse triangle is different. Obtuse triangle is a triangle that contains one angle, just one angle, larger than 90 degrees. Okay, so there's only be one angle larger than 90 due to the 180-degree rule for the sum of the angles in the triangle. So an obtuse triangle could be isosceles or scalene. So this is obtuse because we got this one big angle more than 90 degrees. bigger? Well, let's put bigger than 90 degrees. Okay, so that's that. There we go. And that takes us to the last page. Okay, takes us to the last page. It says here, write acute obtuse triangle example. So classify each triangle below as being the right triangle, acute triangle, or an obtuse triangle. So here we go. So which one is this one? Okay. I don't see. Okay, I see an angle. One angle is more than 90 degrees. Is bigger than 90 degrees. So it is called obtuse triangle. Okay, so I can see that there's one that's bigger than 90 and it's called obtuse. Now you look at this one here. I see that there's a 90-degree angle here. One angle is 90 degrees. So it is called right triangle. Okay. And then over here, okay, so there's no 90 degrees and all of the angles are less than 90. All angles are smaller than 90 degrees. So it is SK, sorry, not SK, talking about angles here. Smaller than 90 degrees, so it is an acute triangle. Okay, there's a lot of vocabularies that we're talking about in here. So obtuse because it's bigger than 90 degrees. You got an exactly 190 degree there, so it's a right triangle. And then here that all of these are less than 90, so that's acute. Okay, and then here's another question. Last question. Martha is building a triangular ramp over a drainage pipe. Okay. She is considering the following designs. Okay, so a ramp. So this is the pipe. The circles are the pipe. And then there's a triangular ramp. Yeah, ramp. There we go. She's considering the following designs. Choose the letter that best completes the statement below. The type of triangular ramp allows the wheelbarrow to be pushed smoothly over the pipe with the least amount of effort on either side. Okay, so you want the wheelbarrow. Well, what is a wheelbarrow? This is just basically this cart that has a handle. There's that's a wheelbarrow, right? So you want to put some stuff in there. So if this is a wheelbarrow that we're gonna push up or push and then down or up this way, okay? Because least amount over. Which one's gonna give me the least amount of effort if I push the wheelbarrow up? Okay. Now thinking about that kind of gives us an idea of, well, which one is that? That all depends not on the angle above, but the angle below. Okay, because we're pushing our cart this way, or our wheelbarrow this way. This actually kind of reminds me of a physics question. Pushing it up. So which one will give me the smallest effort? Now, it's going to be a small effort if the angle below here are less, right? Less. So if this is a big angle above, that tells me that these two angles below are less. So that's going to give me this one. So is it the acute, equilateral, obtuse, or right? It's going to give me the obtuse angle. Because the smaller the angle, it's like smaller mountain to climb. Smaller mountain to climb. Okay. And it says here, justify why this type of triangle should be used for the ramp, making reference to the base angles. If the top angle is big, i.e. the 120 degrees, this allows the base angles to be smaller. Okay, so these are the base angles right there. These are the base angles. If the base, because we have to talk about the base angles, if the base angles are smaller, it would be easier to push the wheelbarrow up on each side. Okay. So that kind of explains everything that we have. So the top angle here that is 180, that makes we only have a small angle to be split between these two. Whereas this one, we have a bigger angle to split it to. Okay, so that concludes our notes. So for I guess for today, we can work on assignment number 1. So assignment number 1 talks about naming the triangle. Examine the triangle below, fill the blanks with appropriate letters for each side or angle. Okay, so if this is angle A, what do you call this side? If this is side C, what do you call this angle? And so on. These ones, number 2 is finding the angle, so using the rule 180. Number 3 is just basically you're gonna circle which one is the correct classification based on side length, and then another classification based on angle. So it's some questions in here. I'll give that with you, or leave that with you for this week, today and this weekend. So I guess that's everything for now. If you have any questions, or if you have any comments, please let me know through email. Okay, so because we can't do a live chat, and we can't do the comments on the YouTube video. So if you have any questions or concerns, let me know on by sending me an email. I actually like hearing from you, um, and yeah. So if you are finished with the test, thank you very much. I received some of your tests. Also, if you are still finishing up the test, feel free to make sure you finish it up and then hand it in as soon as you can. Okay. So have a great day, everybody. I wish all of the moms out there and grandmas a happy Mother's Day, and I will talk to you next week or maybe later if you uh, send me an email. Okay, have a great day, everybody, and I'll talk to you later. Okay, bye.